Hi everyone. As I mentioned, welcome to JAX-NYSCF's virtual classroom. I'm Allie Keene and I work with the New York Stem Cell Foundation. We're excited to have you here today. The New York Stem Cell Foundation, or JAX-NYSCF as we like to call it, is located in New York City. At JAX-NYSCF, we study human stem cells in many different ways to help us better understand and treat different diseases like Alzheimer's, and Parkinson's, cancer, diabetes, and many more. Our amazing researchers are always hard at work, even during pandemics. One of those researchers is joining us today. Dr. Cecile Terrenoire, JAX-NYSCF's Senior Director of Process Development, is here to teach you all about the electricity in your body. Along with Dr. Terrenoire, I have a few guests that are joining us to help answer some of your questions. We have David McCune and Dr. Rekha Iyer. They'll pop up on your screen when they say a quick hello.
Hi, this is David.
Hi, this is Rekha.
You will see them answering questions in the Q&A and noting which questions will be answered live. Dr. Terrenoire, before Dr. Terrenoire starts, I want to give a few quick reminders. Right now, you can hear me, but I can't hear you. It will be like this for the whole presentation. If you have any problems with the webinar, please let us know in the participants chat and we'll try to help you make sure that you can hear everything. We love questions, so there are two ways that you can ask questions. At the bottom of your screen, you'll see a little Q&A button. If you click that, you can type in those questions. You can also raise your hand using the little icon that you see that looks like a little hand at the bottom of your screen. This will let us know you have a question and you want to ask it out loud, and I'll let you know when your mic is unmuted so you can ask that question. The presentation will be about 20 minutes long, and Dr. Terrenoire will answer questions all throughout her presentation as well as at the end. So be sure to stick around even right after she finishes her presentation. JAX-NYSCF's virtual classroom is being recorded, so you'll be able to share it after the fact with family or friends or anyone you think would be interested. We also have a number of other virtual events coming up. Be sure to check JAX-NYSCF's website for some exciting presentations from other JAX-NYSCF researchers. Now I'm excited to introduce Dr. Cecile Terrenoire.
Thank you, Ali. Hi, everyone. My name is Cecile. So I'm a scientist, and I have been working at the New York Stem Cell Foundation for 5 years now. And today I'm going to tell you about the electricity we have in our body, how we make it, and what we use it for. So I'm sure you all know that the electricity in your house, for instance, that you use to charge your cell phone, your computer, to turn your TV on, this is coming from potentially from different sources of energy. It can come from the sun. Let's say if you have solar panels on the roof of your house, the sun is going to hit those panels, and that's going to get this energy is going to get transformed into electricity. You can also use the energy from the water. If the water is making this wheel turn and this wheel is connected to a special machine, that's going to create electricity. Same thing with the wind. But the question is, do you think that our body is using energy from the sun, the water, or the wind to make electricity? Well, it actually doesn't. What we use is the energy we get from the food when you eat fruits and vegetables. So when you eat fruits and vegetables, in the fruits and vegetables, you have vitamins, sugar, fibers, and you also have something called minerals. Minerals are elements you can find in the nature, but that your body is not able to make itself. But these minerals, this is what we use, what our body is using to make electricity. And they have all kinds of complicated names. Like for instance, you have potassium, sodium, calcium, chloride. These are minerals we use to make electricity. So the way it works is that when you eat, for instance, when you eat an apple, you're going to chew the apple in your mouth, and that's going to cut it into small pieces. And then you're going to swallow those pieces. They're going to get into your stomach, get broken down into smaller and smaller pieces. And once you're done digesting your apple, in the end, what you've done is that you've extracted the minerals from the fruits, from the vegetables. And those minerals, they look like teeny tiny beads that contain electricity. This is what we use to charge the batteries that we have in our body. So one battery that we have, it's a battery that's located in the heart. When you charge the battery with those little minerals, that gives the energy to your heart so that your heart can beat. if you didn't have electricity, if you didn't have a battery in your heart would not be able to beat. So that's pretty important. There are other batteries that you have in your body. An important one is in your head, it's in the brain. And it's the same thing, you're gonna have, this battery is gonna be charged with the minerals that you get from the food you eat. But actually the battery doesn't look like this thing that I'm showing here. The battery in your brain, it looks more like this. So this is what we call a cell, and it's actually a brain cell, a cell that's making your brain. The scientific name of it, it's a neuron. And this cell, it's the one that's, it's able to make electricity when it gets the minerals, when it's eating up the minerals. And once it's creating electricity, the electricity is going to travel down this electrical cable. We have 100 billion neurons in our brain. So that's a lot of electrical cables if you think about it. And what happens is that all those cells that are in our brain, they really like talking to each other. That's the, so when they talk to each other, it's a little bit like they were sending a text message to each other, except that what they're sending is just electricity from one cell to another. That's how we are thinking right now. When you're listening to me, when you're watching the slides and you're thinking about what it means, this is happening in your brain. You have this, these cells that are lighting up, that are sending up lightning bolts from one to another, and it's just the way they're talking to each other. So I'm going to show you a little video so that you better understand how it works. So imagine this is your brain, and if you zoom in, you take a magnifying lens, you zoom inside, this is how your cells are looking like. They're sending, they have electrical cables between them, and they're talking to each other by sending a little bit of lightning bolt of electricity down those cables. That's how they talk to each other. So not only we have batteries, in our heart, in our brain, but we also have, and that's not the only place where we have electricity. We have electrical cables that run from the brain to pretty much everywhere in the body. You have cables that are going down your arm to your fingers. They get around your ribs. They get down your legs, down to your toes. You also have electrical cables that are connecting organs, your ears, your eyes, your nose, your tongue, your skin, and also, like your stomach, for instance, or your bladder, as well as your muscles. So you really have cables, electrical cables everywhere in your body. And those cables, we call them nerves. We have trillions of cables in the body. That's quite a lot. And if you were putting them next to each other, they would be spanning over 100,000 miles, I'm sorry. That's quite a lot. The electricity can travel as fast as 250 miles an hour in those cables. And that's actually important. That's something that we need. So why do we need to have all those cables in our body? Well, we need them to be able to sense what's happening around us, to feel what's happening around us. So with your eyes, you're looking at images. With your ears, you're listening to, sounds. With your tongue, you're going to be tasting, the food you eat. With your nose, you're going to be smelling, obviously. With your skin, you can, you have the sense of touch. So you can, if you put your fingers in water, you can tell if the water is hot or cold, for instance. If I'm pinching myself here, my brain knows that I'm pinching my hand, not because I'm looking at it. If I close my eyes, I can still feel it, and I know where the pinch is coming from. And that's because there's a cable, an electrical cable that goes from here down my arm up to my head to tell my head, hey, you know what, I'm being pinched here. So that's the way we're getting info. Our brain is receiving information from our body on what's going on. We also have electrical cables that are connecting the brain to the organs inside our body, like the stomach, the bladder, for instance. When you eat food, after a while, you're going to feel full. How do you know that you feel full? Well, you feel full because your stomach is going to, once it gets really full, it's going to send electricity down the cable up to your brain to tell the brain, you know what, I'm full. Let's stop eating. That's it. Same thing with the bladder. How do you know that you have to go to the restroom? Well, you know, you're going to tell me, well, I know because I feel the bladder is full, but how do you feel it? The way you feel it is because there's an electrical cable between your bladder and your brain. And when the bladder gets full, there's electricity going up the brain to tell the brain, you know what, I'm full, I need to go to the bathroom. And then you have those cables between the brain and the muscles, between the brain and all the muscles you have in your body. And that's why we need to move the muscles, basically. So you need electricity to move your muscles, to exercise, to play all kinds of sports, to dance, to sit down. Right now, like if I'm moving my hands, it's because my brain is telling my muscles to move, in my hands to move, and it's doing that with a cable that goes down my arm and up to my hands. So why is it important that we sense what's happening around us? So one example is shown here. Imagine that you're in the woods and you have an encounter with a bear. What's happening is that your eyes are going to look at this bear, and they're going to describe to your brain what they're seeing. So, you know, they see grass, they see the bear is brown, it has an open mouth, and it's kind of like threatening. So the eye is going to just get all this information and send like a text message to your brain using that electrical cable, that nerve, to tell the brain what it's seeing. And then the brain is going to think about what's happening. So you have the cells in your brain that are going to be talking to each other and try to figure out, okay, what does it mean? And the brain, you know, is going to make sense of what the eye is seeing. So the brain is going to be thinking, oh, well, okay, so that's a bear and it looks really angry. So that's kind of like a dangerous situation. What can I do about it? And so what the brain is going to decide is that it's going to tell you to run away from the danger. And the way it's doing that is that the brain is going to send electricity to your muscles, to your legs, to ask your legs to start moving so you can run away. Imagine that you have this cable between the eye and the brain doesn't work. If it doesn't work, if there's no electricity, then you're not going to be able to see that bear. The bear will still be there, but your brain will not know that there's a bear in front of you. And so if you don't see it, then you know the bear is probably going to eat you, and that's not going to be a good thing for you. Same thing, like imagine that the bear is in front of you, your eye can see it, your eye sends the information to the brain knows that the bear is there, but maybe if you cut the electricity between the brain and the muscles cannot move. So if you cannot move, then same thing, even though you were able to see the bear, then you know the bear is going to eat you. So that's not going to be a good thing. And another reason why we have electricity in our body, it's not just to escape danger, but it's also to prevent us from getting sick as much as possible. So imagine that you're eating an apple, and from the outside, the apple looks good and it's fine. You're going to start eating it. What tells you that the apple is bad and maybe not fresh is the taste, right? And you know that because there's an electrical cable between your tongue and your brain. And so when you're eating, the tongue is going to send a message to the brain telling the brain, you know what, right now I'm eating an apple. But if there's a worm in the apple, the tongue is going to be able to feel it. And it's going to send that information to the brain and tell the brain, you know what, the brain is going to say, well, that's not good. Let's stop eating the apple. That's not good for you. Otherwise, you're going to get sick. But if you disconnect that cable that's between the tongue and the brain, the brain will not know that you're eating an apple that's not fresh, and you're going to get sick. So electricity is really important in your body to keep you healthy and safe. We also need electricity to feel pain. So imagine you have pain in your tooth. If you feel the pain, it's because you have a nerve between your tooth and your brain, and the tooth is basically sending some electricity down this cable up to your brain to tell the brain, you know what, I'm feeling pain, I'm not feeling comfortable. And that's actually important because, you know, none of you like feeling pain. No, I don't like feeling pain, but it's actually important. It's important because if I have a pain in my tooth, probably what I'm going to do is that once my brain has this information, my brain is going to ask me to call the dentist to make an appointment, and then I'm going to have to go to the dentist. And the sooner I do that, the better it is, because the more I have a chance to for the problem to be not too bad and to heal faster. If the nerve between my tooth and my brain doesn't work, if there's no electricity, then my brain will never know that my tooth is not feeling well, and in which means I'm not going to go to the dentist because I don't feel any pain. And things are probably going to get worse than with my tooth, and maybe it's going to end up falling off. So you really need to be able to feel that pain to tell you like, oh, now it's time to take care of my body because something is wrong in my body. And it's the same thing when you imagine you break a bone. You have nerves that are going through your bones, and when you break a bone, that hurts really badly. But even though it's very unpleasant, it's a way your body is telling your brain, you have to do something about it. I gotta go and see a doctor right away. So pain is an important thing. So I hope that by now you believe that we have electricity in our body, and you have a better understanding of why we need it for. And I also hope that you now know that you need to eat your fruits and vegetables because they contain the minerals that you need to charge your batteries. That's really important. Now, I want to mention that, we're talking about being healthy, staying safe and everything, but sometimes people have some diseases. They may have a brain disease where the electricity in their brain is not traveling the right way. And the consequence could be that maybe they have a hard time thinking, maybe they cannot remember things, maybe that's going to have an impact on how they move their muscles. And, sometimes people have their hands that are shaking all the time. They cannot stop the shaking. And that's because the electricity signal between the brain and the hands is a little bit messed up. You could also have a problem with your heart. If the electricity doesn't travel properly in your heart, then your heart is going to beat in a weird way. Maybe you're going to have palpitations, maybe it's going to be too fast or too slow. And that's not a safe situation. So how can we study and understand those diseases to then cure them? Well, imagine you're the patient who has the pain in, like a disease in your brain or in your heart. As a scientist, I'm not going to take a piece of your brain or a piece of your heart to put it in a dish and then study the disease because, well, you need your brain and you need your heart. So what we're doing at JAX-NYSCF, we're using stem cells to be able to study the disease that people have in a dish and then to be able to find cure for the disease. So what we do is that we take the skin cells or blood from a patient, for someone who has the disease, and then we have a recipe for transforming those cells into what we call stem cells, which are kind of like, they have superpowers. The stem cells are cells that can make any cell type in your body. A stem cell, if we have the right recipe, we can transform that into a brain cell or a heart cell or a muscle cell or a bladder cell, like anything you can think about. So I'm not going to talk about too much the details of how we're doing that because we actually have some other virtual classroom that will tell you everything about this. The next one is going to be April 27, and then we have one in on May 13. So just go and check our website to learn more about that. But so for us, for now, I was saying we're going to make at JAX-NYSCF, we're making those cells, for instance, those brain cells from the patient to try to understand why the patient has a disease and how can we help cure the disease. And so we have some sort of like special equipment at JAX-NYSCF to study those diseases once we made those brain cells. So we have here, we have the brain cells in the dish, and then we have sophisticated equipment that give us a chance to measure the electricity that those cells are producing when they talk to each other. And this is here recorded on the monitor. So if you look on the right of your screen, this is how those machines are looking like. You have a big microscope here, and the cells in the dish are going to put like right here. It's a little bit small to see, but it's right here. And then you have a lot of cables and everything that are connected to the machines here and to the machines on the shelf on the side. And so all of those machines, it's like a very sophisticated instruments that can sense like teeny tiny amount of electrical currents. And so it's like if we were using those machines to basically listen to those cells when they're talking to each other. So we do that with cells that we get from people who are healthy, who don't have any disease. And then when we're doing that, so I'm going to show you this video. Here, all those blue circles, each of them, it's one cell, one brain cell. And you're going to see that when they talk to each other, you're going to start seeing some sort of like lightning happening, a little bit like if you were looking at a thunderstorm. That's when the cells are talking to each other by sending electricity to each other. So you have the top one that starts, this one that starts talking, and then all the other ones. Probably this one is saying something really interesting because all the other ones started talking about it after that. I'm going to show it one more time. If this one starts talking, then this one, and then all the ones around.
And Cecile, is that what our cells look like when you're looking at them in the microscope? Are they those colorful cells, or what do they look like when you're looking at them?
Yes, so they are looking, well, it depends on with the microscope, you can adjust the settings of the microscope so that either you're looking at them using what we call the bright field. So bright field image is when you're looking at the cells without any colors, and the image is going to look like black and white. But if you are putting what we call a filter that adds some colors, that's how we're going to see things. We're going to see things with the green and blue, and we can even change that with other colors if we prefer that. But that's just like a way for us, an easier way for us to look at how the cells are talking to each other. Okay, so once we've done that with the cells that are from a person who doesn't have a disease, then we're going to do the same thing with the cells that are coming from a person who has a disease, like a brain disease. And we're going to compare how the electrical signal here, how does it look like compared to the signal we get from a healthy cell. And so in this case, you could say that, well, in a healthy cells, they really like talking to each other. So you have a lot of electrical activity. But here with the disease, for some reason, those cells, they don't really like talking to each other. So you have a little bit of a spikes here, but not much activity. And so that's how we learn about how the cells from a patient, what causes the disease, basically. That's the first thing we do here at NYSCF. And then once we understand what's causing a disease, then we can try to find a cure and test, some medication and see if we apply a medication or another one, does it make the cell look more like a normal cell, a healthy cell, or does it not help at all? So we use all those techniques to use brain disease. We can do that with heart disease too, but there are other diseases that I just want to mention here that we are working on at NYSCF. We work on cancer, diabetes, retinal cells, rare disease, and we also have a team working on bone regeneration. So that's it for my presentation, and I'll just finish with one thing. I don't know if I can stop sharing my screen, maybe. Okay, so if you don't believe that I have electricity in my body, so I keep on telling you we have electricity in the body, right? So I should be able to light up this light bulb. So let's see if I can do it. Oh yeah, it works. So I guess I do have electricity in my body. Thank you, guys.
Thank you, Dr. Terrenoire. That actually poses in great into my first question, which we have from Ethan. It's, if you were able to light that light bulb, why don't we get electrocuted if we have electricity in our body?
Oh, that's a very good question. Wow, good thinking. We have electricity, we have those cables, but they are surrounded by tissue and, like muscle, fat, skin, everything. And all these are kind of like isolating the electricity inside our body from, or from the nerves, from the rest of the body. So that's kind of like protecting, basically, preventing the electricity from damaging us from the inside.
Cool. So our body protects us.
Yes.
We have another question. Are all the stem cell exactly the same, or how do our cells work? The stem cells that you talked about, are all our cells the exact same? Do they look the exact same?
All the stem cells, stem cells themselves, or not sure like what the question is.
So like we have neurons and different types of cells, right, in our body that control each type of part of our body?
Yeah.
Cool. Reka, we have some other questions. Sorry, we're just scrolling through them. And I actually realized that I asked this question incorrectly. So the question was, are the stem cell lessons exactly the same? So we actually have a number of events going on. So Cecile's was about electricity. We have Stem Cell 101. We'll have one about space. So I'll put a link up in the chat for everyone to look at those. We have a question from Kevin. How does your brain sense pain?
Okay, well, thanks for the question, Kevin. So what's interesting is actually the brain itself. If you're just taking it out of your head, the brain itself cannot feel pain. It doesn't have the sensors for feeling pain, but it knows that your body feels pain because of those electrical cables between the different parts of your body and the brain. So when part of your body feels pain, like let's say I'm pinching like really hard here, what's happening is that when there's a nerve that's in my skin that is sending electricity to my arm up to my brain, and that's telling my brain I'm here on my hand.
Great. Okay, I'm just looking through. Reka, do you have a question you want to ask while I sort through some of these other ones?
Sure. Cecile, you had mentioned that we can that certain diseases involve electricity in your body not working properly. Could you cure these diseases by plugging into an electrical socket to get more electricity?
It's more complicated than that, because usually it's a part of it may be a part, let's say a part of your brain that's not working well. And it's not everything in your brain. So it's really a matter of making sure that the electricity travels from one place in your brain to another place in the brain and does it right. So if you were to plug, your head on a power cord, which I don't recommend, by the way, definitely don't do that. but that wouldn't, first of all, that wouldn't work because you have your skin and everything that's going to prevent, the electricity from going exactly where it should be going. But that would only work if you do that, let's say in a surgical setting, maybe like where you can have a sort of wire that's going exactly where you have the problem with your brain and send a little bit of electricity. But if you're doing that on the whole brain, that's probably not going to work.
Great. So lessons: do not plug into an outlet without a doctor.
Never plug any body parts in an outlet.
I'm going to try to ask one of these questions live. Sam Edwards has his hand raised, so I'm going to unmute you, Sam. Can you hear us? Sam, do you have a question? Oh, we'll come back, Sam. If you have a question, just let us know in the chat and we'll come back to you and unmute you.
All right, I have a question from Luis. Cecile, Luis has read about basketball players who, have, died maybe from, electrical problems of the heart. Can you talk a little bit about what that is, what type of disease that Luis might have heard about, and what happens?
Yeah, so unfortunately, that happens not just with basketball players. That happens also sometimes with swimmers, and it can actually happen with kids, unfortunately. This is because when that happens, it's because some of the elements in your heart that make it possible for the electricity to travel through your heart and make your heart beat, those elements are not working very well. And so they're going to receive electricity, but they're maybe not going to be able to send it back to another place in your heart. And so since when your heart is beating, it's beating because it's receiving electricity. If the electricity doesn't travel well within the heart, it's not going to beat. And so typically, these are people that under certain circumstances, quite often these are congenital disease. So they were born with the problem, and it's just happened to develop a little bit later as they grew up. That's the bad news, and usually people find out about this disease, unfortunately, when someone drops dead in the family. But the good news is that the treatment for the disease is very well known, and it's very effective. So if if someone is found to have the problem, there's a medication that can be used for that, and that works very well, and you can live just fine after that. You just learn to know what are the conditions that could trigger you to have a heart problem. And sometimes it's going to be exercise, because when you exercise, your heart is going to beat much faster than when you're resting. Sometimes it's the other way around. Sometimes it happens when you're sleeping, and it really depends on what is affected in your heart, basically.
Thank you. I have a question. Sam sent in his question that he wasn't able to answer or ask out loud. How does the electricity in our body work when we feel something like a shock, like when you touch something and you get a shock?
Well, you can actually get a feeling about it, right? During the winter time, when the air is really dry, you have a lot of static electricity, right? And if you try to open a door, sometimes when you touch the handle of the door, you get a little spark. You get a little bit of electricity. That's not pleasant, but it doesn't hurt you, right? But obviously, if you were to much more electricity, then that could hurt you really bad. You have people who are struck by lightning bolts, and actually a lot of people survive, but if the lightning is first striking you on the head, probably it's going to fry your brain, so that's not going to go well. If it gets your body through, say, your shoulder, maybe you have a better chance to survive. And what it's going to do is probably it's going to burn you a little bit. It may make you have heart problems, because that's going to send a bit too much electricity, in your body. But you can still survive. So the amount of pain or discomfort you feel is really proportional to the amount of electricity you would be receiving.
Thanks. We have a question from Ethan. I'm going to try to unmute you, Ethan, so just give me 1 second. Ethan, can you hear us? Can you unmute your microphone and ask your question?
Do cells make electricity?
Yes. The electricity is made by the cells. So I don't know if you heard the beginning of my presentation, but when you eat food and you digest the food, you get some minerals out of the food, teeny tiny beads that have electricity in them. And these beads are eaten up by the cells. They're going to store those beads, and they're going to use them to make electricity.
There was a question from Kevin asking, how does your brain sense pain?
Wait,
I think we asked that one.
Yeah.
Oh, I'm so sorry.
No worries. We have lots of questions coming in, so sometimes it's hard to keep them all straight. You guys have such great questions. Someone asked, why don't I feel pain when I touch my hair or things like that? So how come some things cause pain and some things don't?
Well, it's a little bit the same thing as, how much electricity do you need to feel pain? What I was just saying, like, if you are touching something that has a little bit of electricity in it, you're not going to feel pain. You're going to feel a sensation about it, like a little spark, but it's not going to hurt you. So with the touching, it's the same idea that you have in your fingers, you can get a feel of what's happening, but it's not going to be it's going to be, that feeling is going to be relayed to the brain through some electrical cables that are not the same one that you use to feel the pain.
Cool. We have a question from Lewis. Is there a way to harness the electricity in our bodies to power things?
That's what a lot of people would like to be able to do. Right now, no, we cannot. We don't have yet the instruments and the technology to do that. But people have been thinking about it. And the in this question is that if you were to harvest your electricity in your body, in, say, a cell phone or a computer, then you wouldn't have any more electricity in your body, so you wouldn't be able to function at all. So we have, in the future, we'll find a way to figure things out, but right now we don't have the technology yet.
We have a question from Emma. So Emma, I'm going to unmute you for a second. Can you hear us, Emma?
Yes.
Do you have a question for us?
Yes.
Go ahead and ask it.
What makes cramps?
Cramps are, geez, that's a very good question, Emma. Cramps, it happens when your muscle gets really, really tight. And when it gets really tight, it's gonna somehow it's gonna pinch the nerve that goes from your muscle to your brain. And when it pinches the nerve, that's how you feel the pain.
Thank you for answering our questions. We have one from, I'm sorry if I say your name wrong, but Kaio. If we made nerves from stem cells and put them back into someone's brain, would it make them smarter?
Well, if we could do that, then I would have done it, and maybe I would be a Nobel Prize by now. That's an you know what? We don't know because we've never done it. But what's really funny is that to show you how electricity can change the way you do things or think. Like, I'm going to go back to the story about the lightning, people being struck by lightning. There's a story about a doctor, a surgeon, who one day got struck by lightning, and he said he wanted to learn how to play the piano, and he had never played any instrument, had never played the piano, but right away he became so good at it that he decided to quit his job as a surgeon and become a classical musician. And so it shows that, if we change things in our brain and we change the way the electricity is traveling in our brain, we can actually do things. And sometimes it's not going to be good. Maybe you're going to mess things up and not be able to maybe think clearly. But other good things could happen. So why not? We don't know.
I guess we'll find out as more to come. David or Rika, do you have any more questions? I know I have a final question for Dr. Terrenoire, but I'll ask that at the very end if you guys have any questions.
Yeah, I think one thing just to add about the cramps question is that it's, as Cecile was saying earlier, it's really important that you have minerals to power all this electricity. And sometimes cramping can be caused by a lack of those minerals, which then disrupts the electrical current. So again, make sure you eat those fruits and vegetables.
Learning about electricity and how to nourish your body all in one. So I'll ask one final question. Dr. Terrenoire, what excites you the most about science today, about your job, while you love working at NYSCF, so that everyone can kind of know?
Well, I think right now, working in the stem cell field is just incredible. I'm working at NYSCF. I'm part of a team that's involved in what we call cell therapy programs. So we are using stem cells to make cells from the eye to repair the eye of people who have a disease and who are losing their sight because of this disease. So it's really incredible to think that we can do that, you know, like 10, 20 years ago, we couldn't do that, but now we know we can do it. And so you can imagine that it shows the power of stem cells and how much we can do with that. You know, like some people are trying to repair their heart with those cells, or, you know, the brain, or, you know, anything is possible. And I think it's very, very exciting to be part of this.
Awesome. Thank you so much for teaching us all about electricity and our bodies and answering all of our these awesome questions that were sent in. If you have additional questions for NYSCF scientists, I just sent a link in the chat. Feel free to send them. I'll also send them a follow-up email in case you miss it, so don't worry. We hope everyone had a great time this afternoon. Be sure to check back to NYSCF.org for more scientific lessons for students, for parents, for scientists. We have something for everybody. One of our next upcoming virtual classrooms will be about sending stem cells into space, so be sure to check that one out. There will be a brief survey right after the webinar. We'd love to know what you think and thought about today's presentation, so let us know. Don't forget to tell your family and friends all about what you learned today, and we'll see you next time. Bye, everybody.
Bye-bye.